Hello, my name is Mr. Wyrick. I'm here to talk to you today about Chapter 10, Lesson 1. All through Chapter 10, we're going to be talking about circles, so there's a lot of information about circles right here at the start. Some of it you've heard before, some of it you will need reminded of, so let's get started. First off, a circle, its locus definition. Locus definitions of different shapes and graphs you'll come back to in Algebra 2. It always begins with a set of all points. So the circle is a locus equidistant from center, or a set of all points equidistant from one center point. So we have the center point, and everywhere that's the exact same distance from it is within this circle. It's what happens when we use a compass. We set that center point, and everything around that circle is the exact same distance from that center point. The next thing to talk about, there's a radius. A radius goes from the center of the circle to anywhere on the circle in a straight line. So any one of those could be a radius. Then you have a chord. When it's a chord, the endpoints of the segment are on the circle. So it could be from over here to over here. It could be from here to here. Anywhere on that circle, as long as both of the endpoints of it are on the circle, it's a chord. A diameter then is a specific chord that goes through the center. Now, I have these kind of expressed out here. You can write them separately or not. You can look at the book too if you want to look at what you want to do for definitions on this. Make sure you're getting this stuff down in your notes. But the radius multiplied by 2 is the diameter, because the radius goes from the center to the outside. The diameter divided by 2 makes the radius. So all the way across, if you cut that in half, you're going from the center to the outside. That's a radius. So the radius and the diameter are interlinked, and you'll do a lot of math today that's conversion from radius to diameter, diameter, radius. The next thing that I talk about is concentric circles. They are inside one another. They have the same center. So if this is my center, make a circle here, I make another circle here, I make another circle here, basically like a bullseye. Those are concentric circles. Now, if this one's over here, and then we have another one that kind of contains it like this, where it's touching the side, those are not concentric circles, okay? They have to share the exact same center to be classified as concentric circles. Most of what you're doing with concentric circles will be just classification. Circumference is all the way around the outside. It's perimeter, but it's specific to circles. And the circumference divided by the diameter is pi. It's an irrational number. The diameter does not go into the outside of the circle an exact number of times, but it does fit a pattern, and that pattern is the number that we call pi. You're used to using 3.14. I'd say from this point on, you either need to write your answer in terms of pi, which means instead of multiplying by 3.14 or pushing the pi button on your calculator, you need to just put pi, the symbol, on there. Circumference is either pi times the diameter, or pi d, or 2 times pi times the radius, because 2 times the radius is equal to the diameter, just like we talked about before. You'll do a lot of calculating circumference. You'll have some overlapping circles, and you'll find some areas in between to use that and find the radius. And once you find the radius, you can find circumference, or if you have the diameter, you can find the circumference. Next thing we need to talk about are inscribed shapes and circumscribed circles. Basically what this is talking about is, if I have, we'll make it kind of a square. It would be a square. It looks like a rectangle in this case. But it's inscribed if the square is what's inscribed if all of the vertices touch that circle. So we can make any shape up to a circle, however many sides, and as long as all of those vertices, all these corners, touch the edge of that, it is inscribed in that circle. And you'll be looking at some inscribed shapes. And then circumscribed is the adjective that we use to describe the circle itself. If we're talking about this square, we could say the circle is circumscribed around it. It touches all the vertices. It goes around the outside. You'll need to know how to find the areas of most shapes. Go back, look over that information from your notes, because it'll ask you about, okay, if this is a square in here and this side is 3 and this side is 3, then how big is the circle? Well, if we take 3 squared, we know that that square is going to be 9. So on a multiple choice test, you know it has to be the area of that circle has to be greater than 9. And the circumference of the circle is going to be greater than 3, 6, 9, 12. It's going to be bigger than 12. Okay, that circle out here, it has to be bigger than what it contains. In this case, if this is 3 and this is 3, then the diagonal, because this is a square, would be 3 square root of 2. So that would be my diameter. So I take pi times the diameter. Area was not on this one, but I'm sure it's going to come up. So we'll look forward to that. On today's lesson, I want you to do 10 through 47. Lots of different information, so there's got to be questions over all the different parts. Take a peek at it before you come back from spring break. And if you have questions, make sure to raise them during class so we can go over this information together. We'll see you then.